Hey guys, thank you for watching my videos. Today I want to teach about Fourier transform. Watch, like, subscribe. Okay, Fourier transform. Fourier transform. Normally we say that Fourier transform, it is f of omega is equals to 1 over 2 pi, that is the square root of 2 pi, integrating from negative infinity to infinity, function of t multiplied by e raised to negative I omega t dt. And today we want to do an example that says find the Fourier transform, the Fourier transform of f of x is equals to 1 and 0, that is by x is less than 1 and by x is greater than 1. So that's our question that we have. Find the Fourier transform of f of x is equals to 1. The first value of f of x is less than 1. Modulus of x is less than 1. F of x of 0, which is equals to 0. Modulus of x is greater than 1. So now to solve this question, first we come and say f of x, that is function of x, is equals to 1. We write like that when we say for the modulus of x. We know normally that modulus is either plus or minus. When we say modulus of x is plus or minus x is less than 1. Therefore we say that plus x is less than, less than 1, and minus x is less than 1. So we can rewrite this in this format: plus x is less than 1 and x is greater than negative 1. So now to combine these two values, because we have a common x here, we say that negative 1 is less than x is less than 1. So that one is our function of x is equals to 1, this one here. So f of x is equals to 1 is this one here. Now we come to f of x is equals to 0. When we say f of x is equals to 0, we need to find these values here, represented by the modulus of x is greater than 1. So therefore we say that modulus of x, for this case now, for f of x is equals to 0, modulus of x is the same as, that is greater than 1, is plus or minus x. Plus or minus x is greater than 1, and that is, now we come and rewrite this one. We expand like the one we have expanded up here. Now we say plus x is greater than 1 and plus minus x is greater than 1. Remember that is plus or minus x is greater than 1. So plus x is greater than 1 and minus x is greater than 1. So we can rewrite in this format: plus x is greater than 1 and x is less than negative 1. Here remember upward here we say that x is greater than negative 1. Here we say it's x is less than negative 1. And when you look at these arrows, when we write here down first, let's write here, we'll say that now combining these two values, we will say that negative 1 is greater than x is greater than 1. So when you look upward here, for this case is fx is equals to 0. This one here we say that is negative 1 is less than x is less than 1. That is the first part. And the second part is negative 1 is greater than x is less than 1. So coming to this side now, we look at the two values now. We need to draw a graph draw a graph to represent the information that we have below here. So this one is going to infinity, this is going to negative infinity. So we have our value of 1, x is 1 and x is 1 here. For this case of f of x, we want to represent f of x is equals to 1 into this graph. So we have our 1 here, and this is our f of x, this line. So now we draw it like that. Draw it like that. It's a curve like that one. So this line is f of x is equals to 1. You see, this is going to negative infinity, so our part is negative 1 and 1. So we have 3 sections in this graph. We have this section which represent of f of x is equals to 0, that is negative infinity to negative 1. Between negative infinity and negative 1, that is negative infinity and negative 1, that is between negative infinity and negative 1. And we have of f of x is equals to 1, which runs from negative 1 to 1. And we have f of x is equals to 0, that is beginning from 1 and between 1 and infinity. So this part is for this part. This other part here is for f of x is equals to 1. This other part is for f of x is equals to 0. So from here now we go to Fourier transform. Remember, we had written our formula there that f of omega is equals to 1 over square root of 2 pi integrating from negative infinity to infinity f of t times e raised to negative I omega t dt. So our function of t is this one. Now we replace this to become our f of x. So our f of x is 1. So we come and write f of omega is equals to 1 over 2 pi integrating from, now we use negative 1 and 1 because our case here we said it is negative 1 and 1. So we write here 1 and negative 1, which is f of x is 1 times e raised to negative I omega t dt. Till there, now we see this is 1, this is e I omega t. Now we need to dissolve this part. Now we need to integrate this section. When we integrate 1 with respect to t, integrating 1 with respect to t, you get 1 t 0 plus 1 over 1, which is equals to t power 1, which is equals to t. So when we integrate 1 we get t, and when we integrate e negative I omega t we get, when we integrate this one it becomes times e I negative I omega over e, this is t here, don't forget, negative I omega. So t times e raised to negative I omega t over negative I omega. This now is our integral that we have gotten. Now don't forget times square root of 2 pi, this all of it. Remember we have our limits, that is negative 1 and 1. So we need to place these values. 1 over 2 pi square root. Don't forget that square root. Need to put our limits. Our first limit is 1, that is t, times e I omega raised to negative I omega times 1 over negative I omega. Okay, minus -1, that is our lower limit, times e minus I omega times -1 over negative I omega. So this negative and this negative they cancel, this negative and this negative they cancel, so we remain with e raised to I omega, negative I omega, because you multiply you get negative I omega still, and negative I omega. Don't forget this, very important. Minus, this is e I omega over I omega. So we can rewrite this stuff to become 1 over square root of 2 pi to become negative e I omega. We start with this part, so we attach the negative over I omega. This minus, it comes here up and become minus e negative I omega over I omega. So we know e I omega plus e negative I omega is equals to 2 cos omega. Do we know also e I omega minus e minus I omega is equals to 2 I cos sine omega. So we come and write down here, we need to remove this negative outside the bracket. So when we remove this negative, this becomes positive. So -1 over square root of 2 pi, you multiply by e I omega over I omega plus e minus I omega over I omega. We can remove, because this one is a common term, we attach it to -2 pi. So -1 over square root of 2 pi, that is, now we are removing this part of I omega, we put it there in front, so that this one becomes e I omega plus e negative I omega. So when we look this one and this one, they are equal. So now we come and say -1 over I omega square root of 2 pi times 2 cos omega, which is equals to -2 cos omega over I omega square root of 2 pi. Thank you for watching. Please subscribe, for this is the solution of the Fourier transform of f of x is equals to 1. God bless you.